Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Sean DuBois. A long time, but not as much a long time friend of the WebRTC community as other projects we featured. Pion is still a little bit of a new kid on the block type of project, even it's very powerful and it's got a lot of features. So thank you for joining us, Sean, and thank you for your project too.
Thanks. Yeah, no, thanks for having me on. I love talking about this stuff.
So would you like to give us a quick introduction about yourself?
Yeah. So I started out working on Pion WebRTC, which is like a pure Go implementation of WebRTC. I think it's just like instead of the pure connection in the browser, you can have pure connection in Go, and you can build SFUs and clients and all the other things. After that, I worked on this book called WebRTC for the Curious. So if you're curious, like you want to know how the protocols and everything actually worked, there's that. And then recently, I've been adding WHIP support into OBS. So there's this, before like the signaling, we didn't have the equivalent of SIP for WebRTC. Like if you wanted to connect to WebRTC agents, there was no agreement on like, oh, do we do this over a WebSocket? Do we do this over HTTP? Like this was left up to the implementers. But there is a new standard that is in the ITF that Sergio is working on that standardizes, just an HTTP post and a response to establish a session. So now there's an explosion of activity to add WHIP to any and all software we can. So that's what I've been doing for the past 6 months.
Well, yeah, there are a few very interesting things going on in the space. So I know you've been doing a lot of work with different protocols, like aside from Pion, which is still a very good project. I'm curious about what you've been doing with WHIP, because I've just recently started reading about WHIP. So if you have a quick intro about what WHIP is, that will be great, and then we'll maybe go into what you've been working on.
So I like to think like WHIP is bringing WebRTC to RTMP, SRT users. Like everyone just wants I just want to send WebRTC to a URL. Like I don't want to have to do all these integrations. I don't want to use your specific SDK. It's allowing us to bring WebRTC into tools like FFmpeg, GStreamer, all these things. So instead of having to write any software, you can just have a URL, or you can just do a GST launch and send video in. And it has become way more useful than I ever expected, because I have all these people that are like, oh, I had someone come to me and they're like, I really want to do SRT to WebRTC bridging. Before, you'd have to write all this code to do it. And now I'm like, okay, here's one GST launch, and you can take your SRT into your WebRTC flow, and there's no like writing any code. And then like I'm starting to see like all these interoperability things where like I'm plugging like different SFUs together, I'm plugging different clients together, and like I'm writing so much less code to do all these things that were frustrating to do before. And then this also is like, it's bringing WebRTC to this whole new group of, broadcasters and all these people that didn't really care about WebRTC because they saw it as like, here's something that I have to write code to integrate two things into. There's no like, take a client and send it to any server. And now that's starting to happen. So yeah, it's like WHIP is a way bigger deal than I ever thought it would be, and it's doing all these interesting things.
Yeah, in general, what are those kinds of protocols used for? Like people are generally used, so this in, I don't say my space, but in a lot of spaces, including where I work, we use WebRTC for communication. So generally two ways.
Yep.
What's WHIP difference? Is there like a broadcasting protocol?
Yep. So there's two. There's WHIP, which is for the ingestion, and there's WHEP, which is for the egress. And right now, like most of the focus is on WHIP, and it's just for like the ingestion of WebRTC. So the big one I'm seeing right now is for broadcasting, and that's really exciting for me because you have all of these broadcasters that are having subpar experiences because of RTMP. So like a lot of people, they really want to do a stream where there's no like back pressure. Like if there's some packet loss, they would rather see some corruption on the screen than like have their viewers, buffer. And so WebRTC is letting us do all these interesting things where I can like, with WebRTC, it kind of puts the power in the broadcaster's hands, where I can say like, okay, like I want 700 milliseconds of delay, and if there's some packet loss, please continue. But for those 700 milliseconds, let NACS and the jitter buffer and everything do its magic. But if it can't fix it in that 700 milliseconds, just keep sending my video. Yeah.
Yeah, that's a very good point. Not everybody knows the difference between WebRTC video and classic like RTMP or HLS streaming, where RTMP and HLS to a degree will try to show you the whole video. So if there's a second of video missing, to make a very quick example, it will wait for 1 second and then resume for there. So now you're 1 second behind the broadcast, so to say.
And it's like it's imagine having a human conversation where like for 1 second you just like delay the entire thing. It's a very frustrating experience. Like as a viewer, I would prefer a little bit of noise than like have this like whole stop of the world. So that's really exciting. And then like, oh, go ahead.
My favorite example is when you're watching a big football game on streaming, and if you're in a city, so there's other people nearby,
Yeah.
they're all watching the big game, like it's the Super Bowl or something. Sometimes you're the one who has the worst buffering, and you hear people cheering, and you don't know what happened. You only know something is about to happen because maybe the play hasn't even started, but people are cheering, so something's going on,
and it's like, it's even if someone tells you like, okay, you're going to watch a movie and there's a big twist, like it's already ruined. Like even if you don't know what is going to happen, the fact that you know something is going to happen, it takes the fun out of the game. No, I'm excited. And then like there's a couple other big ones I'm excited about. So like simulcast, I think is great for broadcasters because right now, if you're doing RTMP HLS, you got to run all of those expensive transcodes. There's all this like infrastructure you got to stand up. There's all this air handling and all this. But now we can put that encoding in the clients, and the clients will do an even better job of it. Because providers are always trying to save costs, so they're going to use the cheapest transcodes. They're going to do it. But as a streamer, I can do the encodes locally with my very nice GPU and have the best settings possible. And I upload that video once instead of having my streaming service decode the video and then re-encode it at 720p 480p. Like it's just going to be a much better experience when we move everyone to this like client driven transcode ladder.
The simulcast is also a very, very interesting thing to use in general for WebRTC. It's making things really easy to do, sending different stream levels, quality, etc. So that's very, very useful. So I know you also work with OBS, right?
Mm-hmm.
Which is probably the standard in this field.
Yeah.
I don't know much about that part of WebRTC, I'll be honest. So what exactly is OBS and how do you leverage it?
So OBS is how pretty much everyone who is like doing broadcast online is authoring and publishing video. It's this like really simple binary download that you pull up and it's able to capture and composite all those sources. So, if like you wanted to lay out a stream and have, hey, here's my webcam up in this corner and here's my gameplay in this bottom right corner. And then it lets you set all of the encoding settings as well. So like for people that are especially doing game capture, it's especially important because it's like with Chromium, you can't just like do a screen capture of your game because there's like anti-cheat stuff that's happening. There's all these things like OBS is actually recognized by these game engines to be allowed to be hooked and it's signed and everything. It's like there's all these things that OBS can do that no one else can't. That makes it super powerful.
It's I've heard that mentioned multiple times, and I was curious. So, what did you do on OBS? You've been working with WHIP and OBS, right?
Yep. So I added WebRTC support to OBS. So now because before OBS could do RTMP and SRT and I think wrist out, and I've spent the last 6 months adding WebRTC support. And so to do that, originally the first version was written with WebRTC RS, which is like the Rust implementation of WebRTC. But since the project is in C++, we ran into all these like packaging problems where it was easy for a developer to build something locally, to build like a shared object and call into that. But then like to put that pressure on like all the Linux distros and everything else would have been too much. And so then we wrote a subsequent version of that using the library libdata channel, which despite the name, actually supports media as well. And like really all we need is video transport. You know, this libdata channel, it packetizes the H.264, it encodes it, and it sends it off, and that's all it's doing. It's like not doing any capture or congestion control.
So yeah, a few questions. First of all, just to clarify, what is a WebRTC stack composed of? Like, I'm asking because I'm realizing we've never really gone through that on the show. So so when everybody says I have a new WebRTC stack, what's in there? What do you need?
So for me, like I break WebRTC down into like 4 distinct parts. It's like the first is you need some way to communicate what you're going to talk about. So that's like the signaling, like the generation of the session descriptions and the parsing of them. The second would be like the connectivity, or the interactive connectivity establishment, ICE, where I know your IP addresses and ports, you know mine. Like, how do we we'll send ping probes at each other and find like, hey, this is the best way to talk to each other. The third is like encryption. So like actually like packaging up that SRTP and being able to encrypt media. And then the fourth is like the actual like the packetizing of those video packets and like the error correction, like if you drop them. And then I think the question, like when someone says I built a new WebRTC stack, there's such I think it's really easy to build like a WebRTC stack, but it's one of those things that's like, it's very hard to build a good WebRTC stack. And so that's what everyone's getting towards. And then like, I always find like once you build, the better your WebRTC stack gets, the less flexible it is. So then like people can't use it. And so you're always like towing this line of like, I want to make flexible software, but if I make it too flexible, then no one can use it, or it's too complicated, or it's not good enough. And so that's kind of what happens. I feel like people build WebRTC stacks with a specific use case in mind. And then the more things they have to solve, the more encumbered it gets.
Yeah, I think there's a very good comparison there to building a SIP.
Yeah.
Stack. Like building a SIP interpreter and something capable of sending and receiving SIP messages is really easy. Like it's surprisingly easy. As soon as you get into compatibility and being able to support various flows, etc., it gets immediately harder, much harder. So it is.
And then like the more SIP things you support, the more libraries you add, and the more like your builds get harder. And then all of a sudden you're like, oh crap, I'm like the heavyweight incumbent.
Oh yeah, that's it. Or it doesn't build anymore because you have an obscure dependency you didn't know about, and you now know because it's suddenly you know. It is. It's very much similar. So yeah. So combining OBS and WHIP, what did that entail? Was it a hard project? What were the steps involved?
So luckily, one of the internal OBS developers had already built a prototype, and so when I joined, I really just had to take, like, he had a gist with some code, and he's like, this is kind of how I want it to look, and I just took it the rest of the way. So like, I think the hardest part of any big project is convincing the owners of that project that, hey, this is worth doing. So I didn't have to do that. Like, I just had to show up and build it. And then from there, I would say the hardest part was that initial frustration of not being able to use the Rust implementation. Like that was tough. Like I had spent months working on one implementation, and then like when I thought I was at the finish line, it was like, actually, we can't do this at all. So you had to scrap the entire project. And then after that, one big one was libdata channel did not support embed TLS. So OBS runs everywhere. Like if it'll run on your toaster. And so like, because, there's so many people broadcasting on so many different platforms, so they have to support all these different TLS libraries. And so like, I had to go and add a bunch of stuff to libdata channel. And that's always frustrating when you're like, you use a library, it works on your local machine, and then you're like, oh, you've got to add all of these additional things. So that was bruising. I remember like that at that point, I felt so burned out. I'm like, I hope this is the last thing I have to do.
So I have one practical question. So to explain to people that maybe are not so familiar with broadcasting, etc. So having WHIP into OBS, what does that allow you to do? What can I do now?
Yep. So
But I
now,
could,
like, yeah, you can broadcast via WebRTC to Twitch, to Cloudflare, to Millicast. There's like I forget, like WebRTC Hacks has an article of all the different providers that support WebRTC today.
so you're compatible with other WHIP
Yep.
WHIP servers effectively. So
Yep.
Twitch and any others who have that. It's,
And those like will offer, they'll have lower latency, they'll do simulcast. You can do more codecs. So RTMP, is an abandoned standard. Like it has, Adobe did it, it's done. So you can do like AV1, you can do H.265, you can do Opus via WebRTC, and you can't do any of that via RTMP.
RTMP is still really everywhere. So
I like it's everywhere. It works. I get like it'll be a I feel it'll be around forever. Like there's some hardware that will never get updated. It'll always speak RTMP, and that's fine. Like personally, I feel very strongly about, and I love WebRTC because I can go to the IETF and I can read the standards on it. There's people that I can discuss it with. There's multiple implementations, and that ecosystem just doesn't exist for RTMP. And I get the arguments for like, okay, we have to keep doing stuff with RTMP, but like eventually, if you want a better future, that future has to start today. Like we can't just keep like kicking this can down the road, and then like there's certain things like people are asking for like the fact like with WebRTC I can do multipath, so I can send half my video packets down one route and half my video packets down another route, like which is great for people that have multiple SIM cards or like other needs, and like we just can't do that with RTMP. And like I get it. Like I get the frustration. Like where people are making money today with RTMP, but I don't want to be stuck with something that isn't serving everyone and for the next 10 years.
Yeah, RTMP is sort of going to be the default for a long time because of hardware investments and stuff, but it's never been great. Again, I find it's useful in very control situations. Like if you really just want to do a broadcast without any particular requirements, I will say you want people to just be able to see your video, then it will work. Yeah. But that's pretty much the only reason why you would do that. Great. So yeah, maybe there's something here. So there's a lot of people who are very adamant on getting good latency out of their broadcasts. So how this is more general, but maybe using WHIP and OBS will help. So this sort of fits in. How do you think people should set up to make sure they have low latency in their webcasts? Is there something I can do, or
so running a public WHIP server? I run one called Broadcast Box, and I can I'm in Ohio and I'm sending my video packets to a server in New York on DigitalOcean. It comes back to me. I see 120 milliseconds of latency, and that's with no tuning, no anything, like, which I think is pretty amazing. Like that I'm able to capture stuff, send it back, and watch it in 120 milliseconds. So I think like I wouldn't even worry about it. Just go try to use WHIP with OBS, and I think your latency will be pretty good out of the box.
Yeah, so all you need to do is really just use the right protocols. It's very simple and very
So just like use the right protocols. Like there's always more tuning you can do with your encoders and other stuff like that. But like you'll be amazed. Like out of the box, it just works.
Does WHIP have? This is probably not some. I don't even know if it's the right question. Does WHIP provision for any kind of transcoding, or do you need something else to do the transcoding, or is it a separate part of the stack?
So for for transcoding, I would recommend simulcast. Like if you have a need for a quality ladder, I would think simulcast is the best way to go. But like built into the protocol, like on the receive side, there's also there's two separate protocols. There's like WHIP, which is for like sending video in, and there's WHEP for playing video via WebRTC. And built into that protocol is actually the ability to like query, like here's all the quality layers, here's how I switch them, and all those things like that. Because I'm also excited for a future where I can go to a website, and instead of everyone having to write a player to watch WebRTC video, you can just do a URL. Just like I can pop in a WHIP URL in VLC and then watch a video, and then I can have the quality selector built in directly to my player. I see a lot of benefit to that as well.
Yeah. So going back to security and maybe private streams, etc. Does WHIP support any kind of authentication or protection, or do you need to set up something in front of it to prevent people from accessing your stream?
So another big benefit of WebRTC over TMP is WebRTC is required to be secure by default. Like there's no like just running it over plain text. Like if you're speaking WebRTC, you are using AES encryption. You know, huge benefit out of the box. And then on top of that, to establish the session, that WHIP uses like an HTTP authorization. So in that HTTP authorization, you send a bearer token or any kind of, you know, authorization. So like it's the same as using RTMP. You know, here's my URL, here's my stream key, and it just goes. Like if you feel comfortable with RTMP today, like WHIP will feel the same.
So it's, yeah, effectively the whole thing is based on HTTP. So it is very much similar in the way it sets up. Well, I think that's super interesting. So another question that comes to mind, will it be possible to use WHIP and WHEP to actually power an SFU style communication? Because that's a strong thing.
Yeah. So this one has been something I'm working on right now, is like, what if I just, because there's a lot of interesting operability, you know, like if you're building an SFU and you just speak WHIP and WHEP, you know, all of a sudden I can connect new clients, I can, you know, send FFmpeg into my chat room, and I don't have any of this problem. So the one problem that I am having is the time to video, because if you have to do another HTTP handshake for each subsequent audio or video track, that's, you know, time that it takes to do the handshake, compared to like if I do something proprietary and have one WebRTC connection and I'm sending messages over the WebSocket and stuff like that, I can get the lower TTV. So my hope is that there's a future where we could have SFUs and all the signaling is standardized, where, you know, I could, because how amazing would it be if I wanted to connect to, if I wanted to have a client on my computer and I could go, okay, I want to connect to Google Meet, or I want to connect to Zoom, and I don't have to like know.
Oh yeah, right, yeah.
Like that would be my dream. And on top of that, the bridging of SFUs. So imagine if like I one person's on Janus, one person's on Media Soup, and I can connect those SFUs to each other via WHIP and WHEP. And now I don't, you know, like now we can start talking about like, hey, like different, you know, SFU providers could connect to each other and like not have, and like have easy bridging. I don't know. I've got big dreams for the future when it comes to like making WebRTC.
Throw an MCU in the mix.
Yep.
Like having someone who's able to provide an MCU out of the same SFU you're in.
Yep.
So you want the SFU view. Here's the SFU view. You want the MCU grid for the people who are in the conference. Zero effort. Just use WHIP to send that the single streams over to the mixing server, and it comes back with another stream that's the mixed video. That is
and how great would that be for customers, that they could like from they could pay one company, they could pay their favorite company for SFU servers, and they could pay their favorite company for MCUs, and they can pick what is best for them feature wise. Like that is what is best for users, to have that kind of interoperability.
You can even have some kind of server side, FX / video processing provider. So instead of having to install a plugin on your computer, or you could have someone in the mix where your SFU is sending the video to a server who's doing the background blurring or whatever, the head centering, and then coming back to you, and it's just there, and you can still use your own providers. Yeah. That would be great. Yeah.
This is why I'm so excited about WHIP and WHEP. Like when the work first started on it, I didn't get it. Like I thought like, oh, like we're just standardizing the HTTP handshake. Like I was worried about things like, oh, like what about like clients that are in the same network? It seems wasteful that they have to go and hit like a signaling server and stuff like that. But now that I've seen like all these different people using it and all the things they're doing with it, like I wish that WHIP and WHEP had happened 10 years ago. Like I can't even imagine where WebRTC would be if we didn't have these 10 years of like people not being able to get to connect things.
Yeah, that will be remarkably complicated. Yeah, I think it's really going to be a good tool for. I think it's a good tool for everything. We've been doing some stuff with WHIP and our MCU to be able to push out the MCU from the mix stream to endpoints. I think it's actually working remarkably well. We'll see where that. I don't know if it's released yet, but it's been something that we've been asked for, so it's coming. Yeah, it's good to have a standard finally. In a world where WebRTC was never truly. So is WebRTC even a standard? I don't even know what the name for the thing is.
Yeah, and it's like there's like WebRTC in the browser, but then the protocol is technically RTC Web in the IETF. And like with Pion, like I just go and implement random standards. And honestly, like these, I feel like 80% of the time, I just am copying what the browsers do. And I'm like, okay, this is what the standard says, but this is what Chrome does. So I'm just going to go do what Chrome does because I can be, you know, all, hey, I'm standards compliant, but I can't talk with anyone else. So it doesn't really matter.
Yeah, makes sense. Well, I mean, Sean, thank you so much. That's super interesting. Everybody should go look into WHIP and WHEP because, frankly, those are probably the future of WebRTC in many senses. And just a quick mention for our audience: next year is the 20th anniversary of ClueCon, so we'll be back in Chicago from August 12th to 15th. And the early bird ticket sale is already open. They're the lowest they will ever be. They'll start at $599. So come join us at ClueCon. Maybe, I don't know, Sean, you've been there, right?
Yeah, I'm in Ohio, so super close to Chicago.
Okay, so we'll looking forward to meeting you there and the rest of the community. It's always a fun event, and the 20th year is going to be even more fun. For many of the people of the community, we're going to bring families and have like a big party. So it's going to be fun. So, well, Sean DuBois, thank you for joining us today.
Thank you so much.
Developer at Twitch, developer of Pion, web expert, and a lot of other things. you have a LinkedIn page that's like half 2 feet long. So I'll just take the top titles. Well, again, Sean, thank you very much for joining us.
Thank you.
The rest of the people, see you next week. Goodbye.